Next, we have Angela Nicholson from Biological Sciences to present RNA regulation, the tail wagging the dogma.
Thank you. Inside each one of your cells, millions of particles are constantly bustling with activity. All of this activity is organized by a molecule called RNA, shown here by these yellow dots. Each piece of RNA is an individual written message, which your genome uses to transmit information out into your working cell. When your cell synthesizes this RNA, it first makes the main message portion. After that, it creates a tail at a predetermined long length. Traditionally, it's been thought that this tail provided protection for the main message, so long was viewed as better. And this was assumed to be the end of the story. So it got written down in a textbook in this way. RNAs have long tails. And sometimes, once something's written down in a textbook, it doesn't get questioned anymore. But sometimes, you find something totally unexpected in your research. My lab has recently discovered that while RNAs might start out their life like this, they wind up with a myriad of tail sizes, and that actually short tails are the most common. But why would your cell bother to make a tail long to begin with just to shorten it up later on? By following these short-tailed RNAs, I've discovered that they actually play a very specific role in signaling to the cell that this particular message should be communicated quickly and effectively. By allowing for long tails on some RNAs and short tails on others, tail length can now be a key part of differentiating each message, being specific to what the cell needs. This finding turns the textbook dogma on its head. Now, I'm talking about a very small molecule and even smaller changes in this tail region, but these findings implicate tail length as a vital part of the message. For an example of how important this is, I want to talk about Fragile X syndrome, which is the major cause of intellectual disability. It's recently been discovered that patients with Fragile X have RNAs with different tail sizes than those who are not affected. As you'll remember, the prevailing view has been that, oh, tails are long and they have no effect on how each message is communicated. So how could they be involved in a disease? Based on my work, we now know that tail length can have drastic effects on development. So working to understand how tails are misregulated in Fragile X could lead to some really important new treatments. This seemingly tiny change on a tiny molecule can affect how the entire human body is functioning. This is just one example of how my research can give us a new lens to reevaluate some very complicated diseases. On top of the scientific implications, this work speaks to the importance of reevaluating long-held beliefs in any field. Scientists once thought that the tail of an RNA was just a passive bystander in regards to how each message was communicated. Turns out, it's more a case of the tail wagging the dog. Staying open and curious in our research could lead to some really big breakthroughs in health in the coming decade. Thank you.
Thank you for telling us your research on RNA regulation and also the implication of the tail links to different disease. This is very exciting.
Yes.
So we'd like to learn more about you. Okay. So you have been doing some work for so long. What are the most impactful person in your life so far in this study?
One of the most impactful people, particularly in regards to this, was one of my professors at my undergrad university. I went to a pretty small undergrad that didn't have much of a science research program, and he was one of the people that really encouraged me to apply for internships and to get a lot more outside lab experience, and encouraged me to apply for my PhD. So he was very instrumental in even down to the nitty-gritty of helping me with applications and things like that.
Good. Sounds like you have a very good mentor.
Yeah.
So speaking of teaching, there's something that you can tell us more about what you like to teach your cat to do?
Ooh, yes. I have a cat, and I really like to teach her to try to catch bugs, because I don't want to kill them. So I've taken to, if I see like some flying thing, I'll pick her up and bring her over there. And she'll be really excited because she loves flying things, and she kills them and eats them.
Okay, what's something that most people don't know about you?
That most people don't know about me. I feel like this is a game of remembering what you wrote on this form. I think what I wrote was that I used to do theater, actually, before my science life. One year I played both a 12-year-old boy and mind you, I was a full-grown woman at this time. A 12-year-old boy and a stripper in a different play in the same year.
Very good. So one last question.
Okay.
What's your favorite destination for travel, for leisure?
Oh, for traveling?
Yes.
I really want to go to Niagara Falls. My friends Jim and Pam had some wedding photos from there that were really beautiful, so I really want to try to get there.
I've been there. It's gorgeous.
Yeah.
So I hope you can go there very soon.
Thank you.
Thank you, Angela.